Okay, hello everyone, and welcome to the demo pitches of the projects Aurora and Protect. My name is Lukas Bernhard. I'm part of the research group HealtH. We are located at the Klinikum Rechts der Isar, which is the university hospital of the TU Munich, and we are an interdisciplinary research group, so we try to bring medicine and engineering closer together. And for that reason, we have doctors and engineers working together on the same research projects and to create more practical applications. We also have a good network to the TU Munich and also to industrial partners, so we are always interested in new collaboration projects and interested in new innovative projects. Today I will introduce to you the research project Aurora, which is short for Auto-Navigating Robotic Operating Room Assistance. So this is a collaboration project between the Technical University of Munich and Franca Emica, Siemens Healthineers, Evo Cortex and the research group HealtH. And the basic idea of the project is to create a mobile service robot for the operating room. So why do we need this kind of solutions? So we have one big problem right now in healthcare. This is staff shortages. And at the same time we have to deal with rising patient numbers and we have to manage the COVID-19 pandemic. So we really need to provide some technical solutions to reduce the workload for the healthcare professionals and the clinicians working in the hospitals. So one very promising technology is mobile service robotics. So this can really help us to compensate for staff that we currently do not have. It can also help to reduce monotonous and non-ergonomic tasks that humans don't really like to execute. And overall, we envision a better resilience for hospital processes, especially in the context of the COVID-19 pandemic, but also for mass casualty incidents. And of course, maybe there are also economic benefits to such a solution. Our vision is not to replace a person completely. We don't think that we are able to do that. But our concept is that the robot will execute certain tasks, such tasks that can be automated quite nicely and are repeated many times, and other tasks that are more suited for human execution are still left to the clinicians. And thereby it becomes possible to perform a surgery with less personnel and allows us to do more surgeries, because right now some operating rooms are not in operation because we don't have enough personnel. So why do we think that the OR ring is even suited for such applications? It seems quite ambitious at first maybe, but we have a rather structured environment, especially compared to the patient ward, for example, with external visitors and so on, or other public places. We are also able to install a sensor infrastructure. So this enables us to do something called workflow recognition, where we try to automatically understand what is going on in the operating room, which phase of the surgery is right now performed. And also the tasks that such robot would execute are very precisely defined. And at the same time they can be supervised and monitored by the clinical personnel. So those are the reasons why we think that such a robot would be a realistic application. Now let's look at different application scenarios. So of course such a robotic solution would be interesting for logistical tasks, bringing material from A to point B, also the management of storages, the adjustment of medical devices, and also cleaning tasks would be very interesting in this context. Here you can see the concept of our research project. So our robot is moving in the non-sterile area of the operating room. So usually you have a division between the sterile area, where the patient is located, the surgeon, the assistant, and so on. Everybody is sterilely dressed. Hygiene is very important there. And then we have the surrounding area, which is non-sterile. And our robot will be moving in this area and is able to access, for example, the storages and also the medical devices, and can execute tasks there. Because the core team is sterilely dressed and cannot walk around in the operating room, cannot walk around in the operating room wing. so our robot can really execute these kind of tasks. Here's a 3D rendering, how our robot, what our robot looks like. We have a mobile base. We have an end effector arm, specially designed end effectors, but we will see a video in a minute, so I think then it will become much clearer. The concrete low-level use cases that we are trying to realize in the framework of the Aurora project is the provision of sterile goods, for example, surgical gloves and suturing material. And the second use case would be the adjustment of medical devices. So the provision of sterile materials follows a standard procedure. So if the human nurse would hand over this kind of materials, the flaps are pulled apart and the material is handed over to the sterile site. And our robot basically is doing the same process. Here you can see a video showing how the robot, after receiving a new task request from the team, is moving to the storage, which is located next to the operating room. In a second you will see how the manipulation arm will take one of the materials that is already prepared in the magazine here. So the robot will pick it up and place it in a special holder on its platform. And of course this is a very early concept, so when we really bring this into the clinic we will need bigger magazines to store all the different kinds of products that we need for the surgeries. Now the robot is moving back to the operating room and towards the operating table and is approaching the sterile area. During that it needs to be careful because the sterile area cannot be contaminated or should not be contaminated. And now the robot is opening the sterile material by pulling apart the flaps on the sides. And the inside, so the actual material of interest, comes out. And now the robot is handing it over to the sterile site. And this last part of the workflow is what we showcase here on our demo booth. The demo booth is located here in the corner of the AI Society, next to the reception desk. So please feel free to come over and check out our demo. And to conclude, I want to say some words about the second use case. The second use case is the adjustment of medical devices. This may seem strange at first, a machine operating another machine. So you might ask, why don't we go for a digital solution? Well, in theory this is possible, but in practice this is often problematic because of company interests, and so we don't have really a completely integrated digital OR system yet. So with our solution we can realize such a thing much earlier, and we also hope that it will become easier for the certification process because we only use such control elements that are already used by the humans. And we are also able to support existing or legacy devices that don't have a digital interface yet. So here's a short demonstration of how the device interaction looks like.
And next to the surgical team we have a graphical user interface, as was already visible in the slides, where the surgical team can monitor the status of the robot. Then we can also see copies of the devices, so we can now see that the insufflator itself is right now turned off. And of course we can use this interface in order to switch on the insufflator, which is now done. Of course in a real procedure we would rather have the surgical team control the robot with natural language, which is also possible. Aurora set 20 millimeter pressure on the insufflator. And now the robot is operating the device.
So as you can see, the interaction between humans and the robot is also a very important part of the project, and this is also something that we showcase on our booth here at AI Society. This is my last slide. Of course, the project has many challenges. We have a lack of space in the operating room. We have a lot of persons, moving objects. We have the unconscious patient and sensitive equipment that we need to protect. We have tubes and cables running through the environment, and we also have sterile surfaces and zones. So this will be very challenging for us to address all of these aspects, but something that we always promote is we don't just want to design the perfect technical system, but we also want to adapt the surrounding environment such that the technology can be applied much better. So please come and visit us here in the booth H1 over there. And now I will hand over to my colleagues that will introduce to you the research project Protect. So thank you very much.